Hello, hi, I'm Ali Mekki, and today I'm going to be discussing the topic of ethanol versus gasoline. So to start talking about ethanol, ethanol is a biofuel. So what are biofuels? Biofuels are non-fossil fuels. They are energy carriers that store energy derived from organic materials, such as biomass, including plant materials and animal waste. They may be solids, such as fuel wood. They come in a lot of different shapes and forms, so they can come as solids, such as charcoal, fuel wood, or they can come as liquids, such as ethanol, which is going to be the main one we're talking about today, or they can come in gaseous form or oil form, gaseous being biogas. Um, so ethanol is a type of alcohol that can be produced using feedstock containing significant amounts of sugar, such as sugarcane or sugar beet starch. Sugar can be directly fermented into alcohol, whilst starch first needs to convert to sugar. The main fermentation process is similar to that used to make wine or beer. So, and pure ethanol is obtained by distillation. The main producers of ethanol would be Brazil and the USA. And also, ethanol can be blended with petrol or burned in nearly pure form in slight modified spark ignition engines. A liter of ethanol contains about 2/3 of energy provided by a liter of petrol. So, however, when mixed with petrol, it improves the combustion performance and lowers the emissions of carbon monoxide and sulfur oxide. Biodiesel is produced mainly in the European Union by combining vegetable oil and animal fat with an alcohol. This is another type of biofuel. Biodiesel can be blended with traditional diesel fuel or burned in its pure form in compression ignition engines. Its energy content is somewhat less than of diesel, 88 to 95%. Biodiesel can be derived from a wide range of oils, including rapeseed, soybean, palm, coconut, and many others. So here are a few differences between ethanol and gasoline. To start off, a gallon of gasoline provides 1/3 or more energy than a gallon of ethanol. Another difference would be that blending ethanol and gasoline at a ratio of 85 to 15, which is E55, it's a type of ethanol and gasoline mix. The blend of the fuel is, is 30% less powerful than pure gasoline. Ethanol is similar in acceleration power and cruising ability when used in a car, but ethanol miles per gallon are less than pure gasoline. So ethanol causes damage to fuel systems and engines that are not made to take in ethanol, that pure gasoline does not. The most critical problem are water contamination and fuel separation. Ethanol attracts and absorbs water, including water from the air. When the gas hole absorbs enough water, fuel water contamination occurs in the car gas tank, and that affects engine performance. If the car sits for a while, fuel separation occurs. This is where the gas and water form layers in the gas tank, and if the motor sucks up the water layer into the engine, it's seriously costly, and it can cause a lot of damage. One other difference, ethanol is an alcohol, and alcohol causes corrosion in the fuel system. Metal parts in the engine can rust, and plastic parts becomes deformed or it can become cracked. Ethanol is not an ideal fuel additive, and older cars especially can't run on ethanol engines. So from this energy content graph here, we can see that gasoline and ethanol you have 76,100 BTU density, and gasoline you have 114,100 BTU density, and then you have E10, E15, and E85. E85 being 85% ethanol, and E15 being 15% ethanol, E10 being 10% ethanol, and their respective BTU densities over there. So as you can see, the ethanol has a lot lower BTU density than the gasoline, so its energy content is a lot less. So here we're going to take a look at the CO2 emissions coming from both ethanol, gasoline, and we have also other biofuels and fuels on this graph. So this is a study done at Stanford University, and it shows you here that the ethanol CO2 pounds of CO2 per kilowatt hour are around 0.5, where gasoline is around also 0.55, a little bit more than ethanol, but not too much more. Here on the side you can see the energy content and the CO2 released. Ethanol 1.6 mole per 1000 kilojoules, coal 2, petroleum 1.6, gas 1.2, and those are the CO2 emissions released by these fuels. So here we're going to be discussing the price difference of ethanol and gasoline. As you can see from the chart, the red is going to be gasoline rack price and the blue is the ethanol rack price. 2010, we start off at a price point of $2 for ethanol and $2.10 for gasoline. As we go to 2012, we're at a $2.7 for ethanol and $3 for gasoline. As we move to 2013, we go to $2.50 for ethanol and $3 for gasoline. And as we move to 2016, we have a $1 for gasoline and a $1.50 for ethanol. So as you can see, the price points of gasoline had fallen dramatically over the years, and ethanol has kept its price point for the most part. So for my conclusion, I'd like to conclude, after putting the two fuels side by side and viewing their negatives and their positives, I'd like to say that it's safe to say that gasoline is a more efficient in both energy content and costs, but it wouldn't be a bad idea to mix ethanol with gasoline so to reduce CO2 emissions, to come up with a type of ethanol as E85 or E10 or E15. Thank you for listening. These are my references below, and have a nice break.